Okay, hi everybody. Welcome once again to this channel. Thank you so much for joining us once again. This is a session on tree diagrams, okay, that has to do with probabilities. And we just want to explore some of the challenging questions, very interesting questions on tree diagrams. And we hope by doing these questions together with you guys, you'll be able to get that deeper understanding of tree diagrams. Okay, without wasting any time, let's get into it. Okay, tree diagram. What is a tree diagram? Just to remind you guys, tree diagrams are often used to calculate probabilities. In tree diagram, it's kind of like a tree, right? That is like a branch of a tree, rather, something that looks like this, where this might be for a certain event, let's call it A, and another event B. And on top of them, there we put what? Probabilities. Okay. So, unlike with Venn diagrams and contingency table, where we can actually put actual outcomes and number of outcomes, in tree diagrams, we only put probabilities, okay, of that particular event. And the key idea that is that in each branch, so this is a branch, the sum of the probabilities, let's say this is 1 over 2, then we expect this also to be 1 over 2, so that the sum of the probability in each branch must be equals to what? Must be equals to 1. Okay, so that's the key idea with tree diagrams, guys. And without wasting any time, let's get into this example. It says a bag has 6 red and 4 blue marbles. The marble is drawn at random and not replaced. This is very important, that you are drawing the marble and you're not returning it back. Second marble is drawn and not replaced as well. Okay, so they want you to sketch the tree diagram. I think this one is kind of very easier. So to sketch for number 1, the tree diagram, so I'm just going to put the branches there. I'm going to use R for red and B for blue marble. What's the probability of taking a red marble? It's going to be what? It's going to be 6 out of the total of them is 10, because it's 6 plus 4, which is 10. Okay, so for the blue marble, it's 4 divided by 10. Okay, do recall that we are doing this 2 times because the second marble is then drawn. So we do this for another trial. There must be a red marble and a blue marble, a red and a blue marble. So now, guys, it's important for you to note that there was no replacement. So they didn't replace. So if they took red and not replace it, then we're left with 5 red out of what? Out of 9. So we are also decreasing the sample space if we are to fetch again the one for red. Okay. But however, for the blue, because in this case, we are coming for red. So for the blue, it will still remain 4 of them out of 9. The sample space obviously has decreased, okay, to 9. Then when we come to this branch, if we fetch the blue at first, what's the probability of getting red? Red in this case, it will just be what? It will just be 6 out of what? Out of 9. Okay, so because here you started with blue, so you didn't affect any number for red, so there are still 6, but then the sample space has decreased because once you fetch blue, you have minus 1 of the blue, so you're left with 9 there. Okay, so if I fetch the blue at first, then second time getting blue, they will decrease to 3 out of what? Out of 9. Okay, so that's the Venn diagram for that. Okay, let's do these other questions. Now they want us to calculate the probability that the first marble drawn is red. Okay, so it's just probability of getting red when we draw the first marble. We already know it from our tree diagram is 6 out of 10. Okay, I forgot something in this tree diagram is to indicate the what? The outcomes. Okay, so here I have red and red. Here I have red and blue. Here I have blue and red. Here I have blue and blue. Okay, so you must always indicate your outcomes in your tree diagram. Did I say Venn diagram? Okay, I think this is a tree diagram, guys. So that is it. So let's go to B. I'm just going to write B somewhere on top because of space, guys. They said, what's the probability that both marble drawn are blue? What is the probability that both of them will be what? Will be blue. There is it. So the probability that we have a blue and a blue, it's 4/10 multiplied by what? 3/9. Okay, then you can get your answer there by your calculator. Let me just quickly move to C. What is the probability that the marble drawn is red and the other one is blue? Okay, so they didn't tell you in which order, just red and blue. Okay, so it can be the probability of red and blue, starting with red then blue, or we add with the probability of starting with blue then what? Then red. Okay, so let's go and calculate that. Starting with red then blue, so red then blue. So it's just going to give us, maybe let me use a white color here. So it's just going to give us 6/10 multiplied by 4/9. Okay, and we say plus, what if I started with the blue one? So it's going to be 4/10 multiplied by, then followed by red, which is 6 divided by 9. Okay, so you can just punch your calculator to get those answers. Okay, let's go to another interactive, interesting exercise. All right, this is your interactive exercise, guys. I just want you at this moment to pause the video and try to answer this question. Then you'll play it again to check if you got it correct. Okay. All right, let's now look at it. It says if it rains on a given day, the probability that it rains the next day is 1/3. If it does not rain on a given day, the probability that it rains the next day is 1/6. The probability that it will rain tomorrow is 1/5, right? What is the probability that it will rain the day after tomorrow? Draw a tree diagram of all the possibilities to determine the answer. Okay, so that is exactly what we're gonna do, a tree diagram. All right, so look, guys, for us to draw a tree diagram in this case, we have to realize that, I mean, we are given the probabilities of like the other branches. Like if it rains on a given day, then the probability that it will rain the next day is 1/3. If it does not rain on a given day, the probability that it will rain the next day is 1/6. So you can see something there that they talk about the next day, right? Then they gives us the probability that it will rain tomorrow. Okay, so this is the trickiness of this question, in that when they say the probability that it will rain tomorrow is 1/5, this is that given day. Okay, so we're like starting on tomorrow, then we'll say the next day. Okay, so we can start our branches on tomorrow. We say, okay, let's start our branches on tomorrow, which will be that given day, right? Or in brackets, I can say that given day, any given day, but we're just saying tomorrow. Okay, so basically, if I do the branches here, the probability that it will rain tomorrow, so there is rain and what? No rain. Okay, so the probability that it will rain tomorrow is what? 1/5. Remember that the sum of the probability in the branches must be equals to 1. So you can determine this one here by saying 1 minus 1/5. Okay, which will give you something like, I think it will be, let me check quickly. Is it 4/5? If you say 1 minus 1/5, so that because you want the sum to be 1, so this will definitely give us 4/5. Okay, that is for tomorrow. Then we can have the one for what? For the next day. Okay, so because we are given that, so let me just put it here, next day. So for the next day, it's either it will rain or there's what? There's no rain. Okay, similarly, rain or what? No rain. Okay, guys, check, guys. We are told that if it rains on a given day, here it rains, then the probability that it will rain on the next day, it's 1/3. So this one of rain is 1/3. Okay, 1/3. Then we can also get the answer of this because their sum must be 1. So we can say 1 minus 1/3. Then you get that one, it will be 2/3. Okay. Then we are also told that if it does not rain on a given day, so this is our any given day, which we are saying it's tomorrow. Then if it does not rain, we are here, then the probability that it rains the next day is 1/6. So this one of raining the next day will be 1/6. So definitely we can also determine the one for no rain because the sum of the branches must add up to 1. So we say 1 minus 1/6. Then you get that 5/6 here. Okay, so obviously guys, don't forget to indicate your outcomes there. So my outcomes, I can just write them as the probability 1/5 times 1/3. It will be 1/5 times 2/3. Here will be 4/5 times 1/6. And here it will be 4/5 times 5/6 as our what? Outcomes. Okay, let's go and answer the question because the question is looking for what is the probability that it will actually rain the day after tomorrow. Okay, what's the probability of it raining the day after tomorrow? Okay, after tomorrow. What's that probability that it will rain the day after tomorrow? That is on the next day. Because we have tomorrow here, the day after tomorrow is the next day. What's the probability that it will rain? So they are looking for something that has to do with rain. Okay, so you can clearly see the outcome of the rain. We have already indicated them. They are there. Can you see? So it's basically the probability that it will rain the next day or the day after tomorrow, because the day after tomorrow is the next day here. So for it raining here, you can see our outcome is basically 1/5 times 1/3, then plus 4/5 times 1/6. Okay, then you can get the answer using your calculator. Let me just quickly do that and see what are we getting. Then we see the correct answer will be 1/5. Okay, so this is the probability that it will rain the day after what? Tomorrow. Okay, it's a bit of a challenging question, really. I do understand, but however, 1/5 should be the answer there. Okay, let's move. All right, let's look at the second interactive exercise. Guys, you can pause the video and try this question and then play it again so that you check your solution. All right, it says a person takes part in a medical trial that tests the effects of a medicine on a disease, right? Half of the people are given medicine and the other half are given a sugar pill, okay, which has no effect on the disease. Okay, so you have 1/2, which is given for medicine, and 1/2 given what? Given a sugar pill. Okay, which obviously has no effect on the disease. The medicine has 60% chance of curing someone, but the people who do not get the medicine still have 10% chance of getting well, right? It's those who got sugar pill. Okay, because I mean it it has no effect on the disease. They say those who didn't get a medicine still have 10% chance of getting well. Okay, so there are 50 people in the trial and they all have disease. So Tawa is one of the people who takes part in this trial, but we do not know whether he got the medicine or sugar pill. Draw the Venn diagram of all possible cases. Then what is the probability that Tawa will get cured? Okay. So it's kind of it seems a lot a bit complicated, but it's quite basic. So the first thing you do is that we know that the half of the people were given medicine. So we have, maybe let me use a different color. We have a branch like this for those who will receive what? Medicine, and those who receive what? Sugar pill. Okay, sugar pill. So we were told half the people got medicine, half of the people get sugar pill. So the probability of getting medicine is 1/2, because it's 25/50, right? Which is 1/2. And also for sugar pill is 25/50, which is half. Okay. So if you get a medicine, you have a chance. So we can also branch again of you what? Getting cured or not what? Not cured. Okay. So similarly with the sugar pill, you have a chance of getting cured or you don't get cured. Okay. So we are told that the medicine has 60% chance of curing someone. So that's like 0.6, the probability of being cured after taking a medicine. Okay. So obviously not getting cured because they must sum up to 1. This must be 0. What? 0.4. Okay. Then obviously those who do not take a medicine still have 10% chance of getting well. It's those who got sugar pill, right? So they still have 10% of getting well, that is of getting cured, so which is 0.1. Then for not getting cured, it's about 90%, which is 0.9. Then you can just show your outcomes of those events, okay? Outcomes. So that will just be 1/2 times 0.6. This is 1/2 times 0.4. This is 1/2 times 0.1. This is 1/2 times 0.9. Okay, so those are the outcomes. But we are looking for what is the probability that Tawa gets cured. What's the probability of getting cured? Okay, so obviously we are looking for getting cured. Okay, so you either get cured if you have taken a medicine, or you either get cured if you have taken a what? A sugar pill. So those are the branches we'll be looking at. So these are the probabilities that we are going to be looking at. Okay, so simply to solve this, getting cured is just 1/2 times 0.6. We either get cured by medicine, or so we're going to add the one for getting cured by sugar pill, and that outcome is 1/2 times 0.1. Okay, so you punch this on your calculator, 1/2 times 0.6 plus 1/2 times 0.1. Then the answer you get what? 7 divided by 20. Okay, so that is it, guys. Let's go to the next exercise. All right, so this is the last interactive exercise, guys. So it says this is very challenging, particularly 11.3, and some of the guys in your class brought it to me to kind of solve it. And it was really challenging, to be honest, but we had to look it again until we can really finally conceptualize it. So 11.3 is very, very challenging because, you'll see when we explain that it's extremely challenging, but 11.1, 11.2, you can get those. I think this is coming from a past paper. And it's quite a very interesting question also to think about in terms of tree diagrams, right? So they're saying Harry shoots arrows at a target board. He has 50% chance of hitting the bull's eye in each shot. Okay. So that is it. They want the probability that Harry will hit the bullseye in his first shot and in his second shot. Okay. So obviously, this does not even need you to draw a tree diagram because you already know that for his first shot, it's either he will hit or miss, right? Perhaps let's just draw it for that one. To say, okay, we know that Harry will either beat the bullseye or will not beat. Okay, I'm just gonna put N for not beat. Let me say beat. Okay, this we know this is for beating. This is for what? This is for not beating. Okay, but I'm just gonna put B and beat and not beat. So here's 50% chance. That's like half, right? Even not beat will be half because the sum of those probability in the branch must be 1. So that's for first trial. Second trial, he can either beat or not beat. If he had missed also first trial, he can either have a chance of beating or not beating. There's still 1 over 2, 1 over 2, 1 over 2, 1 over 2. So we can answer the question, what is the probability that Harry will beat the bullseyes in his first shot and his second shot? Here is it. You can see it's just 1 over 2 times 1 over 2, which is what? 1 over 4. All right. So those are kind of basics. Then the next one, it says calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. So obviously, guys, we are categorizing this part as for the first shot, right? First shot. And this part as for like the second shot. Okay, we do need to get another branches for the third shot. Okay, let me just find space to write this because here definitely we don't have much space. So let me try to put this here. So either beat or miss or not beat is just 0.5 all of them, which is 1 over 2, right? Second trial, beating or missing, not beating, beating or not beating, all of them 0.5 because we are told here's 0.5 chances. For third shot, you have beating and not beating, beating and not beating, beating and not beating. My Venn diagram will look some way, guys. Beating or not beating, but you know all of them is what? Just 0.5, 0.5 there, 0.5, 0.5, 0.5, 0.5, 0.5. I'm very much interested with the outcome of this thing so that we know what must be happening. So here I will have beating, beating, beating. Maybe let me use a red color, beating, beating, beating. Here I'll have what? Beating, beating, and not beating. And I'll have beating, not beating. Let's see, and beating. Then I think we are done with beating. Are we done? So we have another beating. Let's see, did I do correctly here? Because it's beating, beating, beating for the first one. Beating, beating, and not beating. So it's beating, beating, and not beating. And we have beating, not beating, and beating. Beating, not beating, and beating. Then we have B, and N. Then we have B. I think we are done with B. We can go to N, B, B. Then we have N, BN. Then again, other outcomes, we have N, NB. Then we have NNN. Okay, so the question is asking what is the probability that Harry will hit the bullseye at least twice in his first 3 shots, guys. Okay, so at least twice is 2 or more. So we're gonna check when there is B that are 2 or more. Okay, so obviously we have this one, this one, this one. There must be 2 or more, and that one. Okay, so you can just add up their probabilities So obviously for beating, so all probability is just 1 over 2 exponent 3 plus what? 1 over 2, because all of them are just 1 over 2, 1 over 2 exponent 3 plus 1 over 2 exponent 3 plus 1 over 2 exponent 3, because there are 1, 2, 3, 4 of them. Okay, so when you do that on your calculator, 1 over 2 exponent 3, 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 the answer is just half. So there's still half a chance that Harry will hit the bullseye. Okay, let's now go to 11.3 and particularly do this separate on another slide. Okay, so 11.3 is saying Glenda has also 50% chance of hitting the bullseye on each shot, right? Harry and Glenda will take turns to shoot an arrow, and the first person to hit the bullseye will be the winner. Okay, calculate the probability that the person who shot first will be the winner of the challenge. So this is quite a very difficult question to conceptualize. I mean, I did it with other two students, and we kind of struggle a lot with it. But I'll try my level best to explain how we go about this. Right? So we are being told that there's another person near Glenda who will be taking turns with Harry, right, about shooting this bullseye. And the key idea is that the winner is the person who will hit the bullseye first, right? What is the probability that the person who will shoot first will be the winner? Okay, that's where we are. Calculate the probability that whoever will shoot first will be the winner of the challenge. Okay, so to do this, we're going to use obviously a tree diagram. And I want us to say, okay, between Harry and Glenda, let's choose perhaps Glenda to be the person who shoot first, right? Then we're going to look for those probability that if Glenda is the person who shoot first, will be the winner, right? So if Glenda is shooting first, obviously she has two chances, that is beating the bullseye or not beating it, right? Which is just 1 over 2, 1 over 2. Okay, so we are deciding that, okay, let's start with Glenda. And we want to see if we have started with Glenda, what's that probability that starting with Glenda, the person who start will be the winner. Okay, so obviously Glenda will only be the winner if she beats the bullseye. And that probability, we already know it. It's what? It's 1 over 2. But that's not the only possibilities, guys, right? What if our choice of Glenda, because we are choosing Glenda, right, to be the first person who start first. But let's say Glenda then misses. Okay, then what happens? It's Harry's turn, right? So we're going to call Harry. Harry now. And Harry has also what? Two chances. That is, he can either beat or what? Or not beat, right? So still the same probabilities there. Okay, so we are saying our Glenda, who was our first choice, let's assume she didn't beat, because we are saying, let's assume she's the one who shoot first. What's the probability that she will hit? It's 1 over 2, right? That is it, we have written it. But we are saying there are other also possibilities that this person who's starting first might miss. So we are assuming she missed. That's why I'm putting wrong there to show, okay, let's say our first person who had to shoot has missed now. So we then call Harry, and obviously because our focus is on Glenda, we want to determine those probabilities that the person we called first will be the one to hit, right? So obviously when we call Harry, let's assume also Harry does not beat, then we then call again who? It will be Glenda's turn, right? So we call Glenda again. So Glenda will have obviously those two possibilities. It's either Glenda will beat or will not beat, right? So this is 1 over 2, 1 over 2. But guys, we are particularly interested in this first person we called first, and we want to see what's the probability that they will be the winner if they hit first, right? So in this other possibility that we are looking at, we are saying we have called Glenda again for the second time, but in this case, what's the probability that this Glenda as our first person will hit the bull's eye? Okay, so it's not just 1/2 because there's already things that have happened previously. Your Harry has missed, Glenda at first had missed, Harry had missed, which is 1/2. But in this case, the probability that they will win will be 1/2 times 1/2 times 1/2. That's another possibility. Okay, so it's 1/2 times 1/2 times 1/2. Okay, because we are interested in the person who was called first to say what's the chance that they will beat. So the first case is when we caught them first and they hit. That's just this 1/2 we have written here. This second case, now we are saying, oh, it can happen that they had missed, right? Then we call Harry, missed, then we call again Glenda, then maybe she beats. What's the probability that she'll beat when we call her for the second time? So it will be 1/2, 1/2 times 1/2, which is basically 1/2 exponent 3. Okay, but again, there are other also possibilities. What if when you call Glenda for the second time, she disappoints you again, she doesn't hit the bull's eye? Whose turn is it now? It's Harry's turn. So with Harry again, there are two possibilities, either beat or what? Or not beat, right? Which is still 1/2, 1/2. But let's say no, even this Harry, because we don't want Harry to beat. We are interested, our focus is on Glenda as the first person, because the question is saying, what's the probability that the first person you call will be the winner of this challenge? And the first person we call must be the one who beat. So we don't want Harry to beat. Okay, obviously we don't want him to beat. We want to call again this Glenda so that she kind of gave us that probability of the first person who was called here to be the one to beat. Okay, so there are still two possibilities, either she'll beat or not beat. Okay, so it's 1/2, 1/2. But then this is another case, guys, that, okay, you have now called Glenda for the third time, right? But you can see that you can determine the probability that she'll beat. Okay, so but this probability now it's drawing back the tracing it back there, 1/2 times 1/2 times 1/2 times 1/2 times 1/2 when she beats, when she's called for the third time after missing for about 2 times. We call her third time, and because she's our first person, the probability that she'll beat when we call her for the third time is this 1/2 1/2 1/2 1/2 1/2. So it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Okay, but you can see, guys, that this thing can happen continuously downwards going to infinity. Can you see that we'll keep on adding this probability that the first person we have called will beat? Okay, because the first case is when she's called and she beat, is that 1/2 we got. Then the next case is, what if she had missed? Then we call Harry. We don't want him to beat, we want him to miss. What if he also miss? Then we call again Glenda as our first person to say what's the probability that she'll beat, which we got as 1/2 times 1/2 times 1/2. Okay, then that was the second case. Another case, when we call Harry, then we call, he misses, then Glenda comes and beat again. That probability is this. Can you see that this thing will continue to infinity? We'll keep on adding, because we can also say, what if Harry now miss? We have to call again Glenda to come again, like that. So you keep on adding. Then you have to realize that this sum will be going to infinity. That's why this question is kind of very difficult to comprehend, because it's kind of give you that sum to infinity of the probabilities of the person that we are calling first to be the winner, that is to be the one who hit. Okay, so you do it by cases like this. So you realize this is 1/2 and this is 1/2 exponent 3 and this is 1/2 exponent 5. And we are adding this to infinity. Can you see? It's forming a sequence here, guys. If you can check, this is a geometric sequence because we can see the common ratio here is just 1/2 squared. Okay, if you calculate R, the common ratio, It's 1 over 2 squared, which is just basically 1 over 4. And we have our A, which is 1 over 2. Then to get the sum of these answers, because we are adding this probability to infinity, how do we add numbers to infinity? Can we say we cannot do it? Fortunately, we have the sum to infinity of a geometric sequence, because this is a geometric sequence. So to get the probability, we'll have to get the sum of infinity, because this thing will be happening, can happen indefinitely in terms of these cases. Okay, so in terms of this probability that the person who shoot first will beat is basically that sum to infinity of those probabilities, which is A. I said it's sum to infinity, which is A over 1 minus R. So our A is a half, then over 1 minus R, which is 1 over 4. Then you can get the answer of that, and then you can just punch your calculator 0.5, which is half, 1 minus 1 over 4. Then the answer of the sum of those probabilities will add up to, let me just put it maybe in red color. The answer is 2 over 3. So there is 2 over 3 chance, which is about like 66%, 66.7% chance that the person that we are going to call first, in this case we choose Glenda, will be the one to hit. So this question really, 3 marks for having to think like this. It's really a lot. You can rewatch the video and just re-listen it carefully if you didn't comprehend it, so that you can fully comprehend it. Okay, that's it on my side on tree diagrams. Till we meet again. See you soon. Bye for now.